Hello there. So this right here is my Lab 2 project. Let me just explain real quick about the circuitry, at least on the ESP32. So it is already in the breadboard. It's connected with a USB-C to my computer. And just for the actual wiring itself, so basically the LED anode, the positive side of the LED, has a 220 ohm resistor connected to pin 27 for the PWM. I guess, side of things. And then there's also a potentiometer, which the middle pin of the potentiometer is connected to, as in accordance with the Lab2 report, with ADC1 pin, which in this case would be A2, or also GPIO 34. And then the other two channels of the potentiometer are connected to at least in each respect. This one right here will be connected to VCC, specifically the 3 volts from the ESP32, and then also this right here for the other channel for the potentiometer is connected to the GND of the ESP32, and they're all connected through this rail, which the 3 volts and the GND of the ESP32 are connected respectively to each of their positive and negative rails. And then also to note, the cathode side of the LED, which is the negative wire, the short, I guess the short pin, I guess, is connected to the GND rail as well in order to make this all possible. And that's pretty much it, at least for all the wiring. So let me actually run this code real quick. And yeah, so this right here is in Thonny. It's already connected to, at least like the interpreter is already connected right here. So I just got to run the code. Let me see, just run it. And then before anything starts, boom, this thing is already blinking. So this right here is at 10, my apologies, 10 hertz, at least for the frequency, and then the duty cycle's at 512. And yeah, it's just gonna be like this for now, if I don't make any major changes. So let me just go and actually start the first portion of the lab, which is basically just putting down the time. So right now it is 2026. So it's going to ask me for the year, and then next it's going to ask me for the month, which is going to be March. So it's 3rd. Day, today is at least the 8th, at least when I'm recording this. And then the weekday, which is also a Sunday. So again, with accordance, right here, basically 0 represents Monday, and then up until 6, which represents Sunday. So because it's Sunday, I'm just gonna put 6, and then hour. Now in the actual time, I got 7:35, and I'm using military time, at least for this code right here. So it'll be 12 plus 7, which will be 19. And then for the minutes, it'll be 35. And this might actually change real soon. Oh, actually, yeah, it already kind of changed real soon. I guess I was a little too slow, but it's perfectly fine. And then the seconds, at least because I don't really know the seconds at the moment, so I'll just put 00, and then microseconds should be 0.0000000, which is just 6 zeros. And then it just prints out what the LED is blinking at least for the frequency, which is 10 hertz, and then a duty cycle, which is 512. And then after like 30 seconds, you could just look at the timestamp of the actual video to check. But basically, it's going to print out the time after I wrote down the time inside the actual shell. So just give it a bit of time overall. And yeah, that's pretty much it, at least regarding this. And then, yeah, there we go. It's already been 30 seconds, and then it just tells me the two printed lines of the actual date, which is just the year, the month, and the day. So 2026, March 8th, and then also the weekday, which is Sunday. Whoa! And then also the time, which is, again, military time, so it'll be 19, which is the equivalent of 7 p.m., and then 35 minutes, and then 30 seconds, and then the microseconds. Now, the microseconds has some numbers just because there is a delay every time you run the code, just because of the chip itself. It's just not that fast enough per se. So there will always be some little like lag, which is pretty minor. It's just one, if I want to round it off, just 1 microsecond per se. Oh, or yeah, yeah, just in this case, I suppose, or 1106. Yeah. So that's pretty much it. It also tells me the time zone too, which is EDT. So, at least for this code. And then, as we can see right here, as stated in the actual lab, if I change the potentiometer, it will do nothing unless I do a button press on the actual ESP32 board, which is going to be this button right here, which, at least in the code, is labeled as 38. And basically, when I press this button, and again, the potentiometer is not going to change. Not regarding its duty cycle or its frequency, but up until I press this button. So when I press this button, let me see if I can show it. And then, yeah, as you can see right here, it just keeps on going forever, at least with 30 seconds. And it'll keep on doing that even though I'm changing the duty cycle or the frequency. So again, when I press this button, boom, it's going to print out, okay, I'm in frequency mode. As you can see, it's currently in its frequency mode. So if I'm at the very edge, there's pretty much no blinking. Yeah. Because this would be just controlling the blinking side. But if I go, so this was right here, counterclockwise. So if I go clockwise, it's going to start blinking, as you can see right here. Oh, there we go. It goes blinking, 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 blinking. And then even does it where like there's like some gaps. Yeah, or if I go to the very end, that's how big of the gaps will be in this regard. So yeah, that's pretty much it. And then let me just show you. So if I go back to, let's just say right here, as you can see, there's like a little bit of a gap right here. Now, if I press the button again, it's gonna switch to duty cycle mode where I'm gonna control the duty cycle and it will not affect the frequency of the actual LED. So if I do this, it's gonna print out, whoa, second button press, duty cycle mode. And then as you can see right here, this right here is just controlling the brightness. So it will be at the same frequency that it's doing. And it's kind of hard to see because the camera cannot read it, at least from what I can tell. Because at least with me, it's showing that there is a frequency, yeah, like right here. Yeah, because there is a light being emitted, but I guess the camera just can't really detect it too well, at least with the FPS. But I could control the brightness just by doing this. Ta-da, as you can see, it gets brighter, it gets brighter, it gets brighter, it gets brighter, boom. And then I can even decrease it to the very end. And the frequency should be the same, so it'll be the same blinking rate. As you can see right here, I can go to the very end where you can't even see it. So yeah, and then boom, boom, boom. And then just to show you real quick, let me just do the full on brightness, or yeah. And then let me go switch it again, and then it should be like this for any type of frequency. So I switch it again, it's gonna be again at frequency mode, it's gonna be super bright. And then pretty much as you can see, it still blinks, but at that brightness. So it's really hard to tell, at least with the camera, yeah. And just to show you the actual dimness of it all, if I go to the edge of the blinking mode where it doesn't even look like it's blinking, I can go click it into duty cycle mode and then bing bing boom. It should just show how dim I can be if I go clockwise or how bright it could be when I go counterclockwise. So yeah, that's pretty much it. And then as you can see right here, the timestamps are still going every 30-second intervals. So yeah, like right now it's like 1940. And yeah, again, I was a minute off, at least when I was setting this up. So as you can see, it's pretty much accurate. But yeah, that's pretty much it for the code and also the circuitry and hardware. Yeah, that's more or less it. And yeah, hope you enjoyed it.